Good evening, my fellow scientists. It is Friday, November 3rd, 2017. I want to say a huge thank you to the folks who've liked and shared and subscribed and contributed to the Iron Battery crowdfunding campaign. It means a huge amount to me that folks are willing to contribute to support undergraduate education and the development of this interesting and potentially useful technology, the iron battery. So if you'd like to have a look at that project, the link is in the description. Again, thank you so much for all the support. It just means a lot to me. Today I want to talk about aging because I saw a great video on aging and death by CGP Grey. The link is also in the description. Of course, this is a huge subject and a great channel in general, and right after I watched that, I saw an article came out about aging and death and the inevitability caused by our fundamental limits of biology. And I don't know that I agree or disagree with the paper. I don't know that I'm qualified to agree or disagree. I'm not a evolutionary developmental biologist. I'm a chemist, and the simulations are outside of my wheelhouse. But I think that the notion is easy enough to understand, and I want to get some thoughts out about it. The idea is that there's no huge evolutionary pressure to keep people healthy in old age. Once they have procreated, they're essentially genetically expendable, and evolution does not work hard to preserve old organisms. And so maybe with the right tweaking, you could make biology last a lot longer. If you put selective or design pressure on biology, could it not last indefinitely? And the Society for Negligible Senescence has tried to do just that, to look at the process of cellular aging, how that contributes to organism aging, and how to shut it down, which is really, really cool. And I certainly hope that this paper is wrong, but the paper, link in the description, is taking as a premise the idea that aging is, and senescence, old cells that are shutting themselves down, are there in order to prevent cancer. So there's really two pressures. One, live longer, live healthier. Two, prevent cancer. And living longer and healthier means cells need to live longer and not go into a senescent, shutting down kind of state. So it would be healthier if those cells stayed as active as possible, as long as possible. On the flip side, if you don't put checks on cells, if you don't shut them down when they start to get wonky, you greatly increase the chances of a mutation causing cancer. And if those two pressures are in some sort of dynamic equilibrium such that we're already at the optimum, then there may not be a lot to be done as far as drugs and therapies are concerned to extend life and health. Because if you extend life and health by shutting down senescence, you increase cancer. If you decrease the propensity to form cancer, you do so at the expense of healthy cells and potentially shorten life. So is there a way around this? I certainly don't know, but it does sound plausible, and the simulations they did back up these plausibilities with math. But I have not yet seen a particular great mechanistic study that looks at these two in balance and shows that they're there. So, links are there. I think it's neat to think of shutting down aging. I hope it's possible, but I'm afraid CGP Grey may be wrong, and in fact, we're already at about as good as we can get biologically. That's not to say there might not be non-biological ways of life, as it were. But I digress. If you like thinking about chemistry and science and biology and analyzing the questions of eternal life, well, tune in Monday through Friday. We talk about all that and also about iron batteries right here in the Allen Lab.